really this talk is about dispelling a bunch of myths that I've seen over the past decade or so when I've been traveling the world and doing consulting and training and that sort of thing. And the first myth I want to dispel is probably the biggest one. And whenever people think about software architecture, they normally think about big design up front. And these two things are not the same. So, of course, historically, there has been a tendency towards big design up front. This is very predominant in the 80s and 90s and maybe the early 2000s to some extent. This is the old waterfall thing, kind of looks like this. We've seen this 1,000 times before. This diagram, this image actually comes from a paper written in the 1970s by Winston Royce. And he's describing different approaches to software development. And he actually says this underneath the illustration: I believe in this concept, but the implementation described above is risky and invites failure. So what he's actually saying all those years ago is, this kind of makes sense, but please don't do it. And if you read further, what he actually talks about is what we really now know as the agile and iterative and incremental approaches to software development. So a bunch of stuff happens through the 80s and 90s, including some of the very early agile stuff and rapid application development and DSDM and things. And eventually we get to 2001 and the creation of the Agile Manifesto. The Agile Manifesto says this on the front page: we value responding to change over following a plan. And of course, at face value, this seems to throw everything we've ever known on its head. And what I've seen over the past 20 years or so is that many organizations have flipped from doing big design up front to literally nothing at all. And both of these extremes are not great. And there's a great quote I'd like to use here by Dave Thomas. And he says this: big design up front is dumb. Agree, for a whole bunch of reasons. And doing no design up front is even dumber. And this really epitomizes what I've seen over the past couple of decades or so. So the big question everybody's kind of really wanting to have answered is, well, how much upfront design should you do? Now, of course, Waterfall says do all of it, and Agile, on the face of it anyway, seems to suggest not doing any at all. And the answer is, well, you need to figure out what it is you're doing, and it depends. What does it depend on? Sometimes you know what you're doing, and sometimes you don't. So if you're working in a big enterprise environment and you might be doing a system replacement, you might have a fairly good fixed idea of what you want to be delivering. If you are creating a startup company and putting a product out into the market for the first time, you've got to do the MVP thing and get some feedback and experimentation and so on and so forth. So in that situation, you might need to take a slightly different approach. So the general way of describing how much upfront design should you need to do is really, well, we need to do just enough. Hooray. What does that actually mean? I think the problem with upfront design is that it paints a picture of putting a perfect blueprint, a perfect end goal, an end state. And that's not really what we're trying to do here. I don't think we're trying to create that perfect end state or complete architecture. I think we're trying to do something else instead. There's a great blog post by Josh Kirievsky. It's called Evolutionary Design, subtitled Beginning with the Primitive Whole. And this is a thing we've seen 1,000 times before as well. So you put out a first version of something and then you add features, get some feedback, and so on and so forth. The thing very few people talk about is, how do we actually get to that first version? So in order to do the iterative and incremental thing, we need to have a good set of foundations. We need to choose, in this case, the overall shape, the starting materials, potentially the extension points we think we might want to use in the future, and so on and so forth. So we need to put some design, some thinking into that initial first version. And that's really what I'm talking about here. It's about adding that starting point, creating that starting point. Why do we want to do this? Imagine you're starting out on a new software development project or product, and you're sketching out some ideas on a whiteboard. When you are sketching out those ideas, either on your own or collaboratively, and we'll talk about that later, you really want to be able to answer two basic questions. Number one, do the diagrams we are drawing, do they reflect what we think we actually want to go and build? And question number two, how confident are we that that design, that solution is actually going to work and be feasible? In order to get to the point of drawing diagrams on whiteboards, you need to make some decisions. And there's a really nice quote by Grady Booch where he talks about the definition of architecture, or his definition of architecture. And he says this: architecture represents the significant decisions where significance is measured by cost of change. And the reason I like this definition of software architecture is that it really says some design decisions are more important than others. If you were to go and write down all of the decisions you've ever made on your current product or project and try to sort them by how important or significant they are, what you'll find very quickly is that it's very hard to draw a line between all of this stuff up here is significant and all of this stuff down here is not significant. So it's a gradient of different types of decisions with different levels of significance. The ones we really want to be focusing on, the ones that are hard to change ultimately, are things like choice of language. So is this going to be a Java monolith or a Ruby monolith? You know, once we've chosen our language, that's kind of hard to change. The overall structure of the thing we're building. So if we choose to build a monolith, converting that to a microservices architecture is something that involves quite a lot of time and effort. And of course, the opposite is true. So really, a lot of these significant decisions revolve around technology choices, major technology choices, the things that become ingrained into our code bases, and the way that we use these technologies in terms of the structure and the modularity. One of the things to be careful of here is many teams will say, it doesn't really matter about technology choices, because what we're going to do is we're going to build a Java monolith and we're going to use ports and adapters, or Uncle Bob Martin's clean architecture. So we're going to isolate all of our business logic and make all of our tech choices deferrable and decoupled from our code base. That's fine, but that has a set of trade-offs. And the significant decision you just made is one around structure, and that has its own set of trade-offs. So what's not important? Curly braces, white space, tabs, all of that stuff, don't care about. I know we have all these religious debates, but it really doesn't matter. We can just chuck some tooling at it and fix it one way or the other. There's lots of material out there on Agile architecture. Something I like is Scott Ambler's approach, and he has a great essay on Agile architecture that you can basically summarize in one sentence like this. You should base your architecture on your requirements. So in other words, don't make decisions unless you have reason for making those decisions. Travel light, so do the just enough thing, you know, be agile, and make sure you prove your architecture with concrete experiments. What's a concrete experiment? Is nothing more than these things: proof of concept, prototype, a spike, a tracer. We have lots of different names for the same thing. The same thing is basically writing some code to prove our hypothesis. And I like to include the concrete experimentation as a part of my upfront design process. One of the more interesting questions here is, well, how do I know which concrete experiments to run? How do I know which bits of my system I want to prototype before I start getting into writing lots of production code? Something that the Rational Unified Process said all those years ago, RUP, is that we should identify and mitigate our highest priority risks. And I think this is a great thing to do today. RUP was a risk-driven approach to building software, and it front-loaded all of the big risky stuff to the start of the project lifecycle. There's a bit of unpacking to do here, which we don't have time for, but feel free to ask some questions afterwards. You know, what's a high priority risk versus low priority risk? And also, how do you identify risks in the first place? One of the typical techniques we've used is we'll get the single project manager or the single architect to go write a list of all the risks that they perceive with that solution. That's not particularly a good way to do it, because risks, much like estimates, are subjective. So there's a technique I created a while back. It's called risk storming. And it's a visual, collaborative, kind of game storming inspired approach to identifying risks collaboratively as a group. So that's something you can go look up online. To go back to the how much upfront design should we do question, what we're really trying to do here is we're trying to do enough upfront design in order to put that starting point in place and set an initial direction. And I do want to stress that's an initial direction. So I'm quite happy for the set of decisions and the solution to change as we deliver stuff and get feedback and have real users using our software. But any changes we make should be done in a structured and justified manner. One of the other ways to think about upfront design is, well, when do we stop? And I think upfront design is an iterative and incremental process. So it might be something you need to do one or more times. And you should stop when you can do this type of stuff. So you have a good idea of what your context is, what the scope of the system is you're building, how it fits into the world around it, what the key requirements are, what the key non-functional requirements are, and those sorts of things. So really that's my kind of one takeaway slide about how much upfront design should we do and when should we stop. So that's thing number one. Thing number two is that every team needs to think about all that stuff. What happens if teams don't think about architecture? You get a mess. Chaos. Chaos manifests itself in a whole bunch of different ways. Big balls of mud, spaghetti code systems, code bases that are just horrible to work with. Code bases with inconsistent approaches to solving the same problems. So I've seen a number of code bases over the years with multiple logging frameworks in the same monolith, multiple database access frameworks in the same monolithic code base, and so on and so forth. I've seen systems that are hard to deploy, hard to look after, hard to maintain. Logging's a problem, or they don't have appropriate quality attributes like scaling and security and performance. So that's the category of stuff that I think doing some upfront design and architecture really helps to address. And all of that stuff is applicable to every team. One of the ways I like to think about software architecture is that it's about technical leadership. And when you think about it that way, you kind of quickly realize that actually every software development team needs some degree of technical leadership. If you're a one-person team, you need a small amount of technical leadership. If you're a 100, 200, 1,000-person team, then you need a much bigger degree of technical leadership. But nonetheless, you need technical leadership. I'm also going to say this: every software system or every product also needs technical leadership. And the reason I say this is because I see lots of teams these days adopting things like the Spotify model, where you've got squads who are working on business features, and they might be given autonomy and authority to change multiple pieces of code and multiple repositories on multiple products. If that scales up, what I've tended to see happen is that because you've got all of these teams potentially changing the same code bases, because there's no single ownership of those code bases, sometimes the teams start making changes in very inconsistent ways. So do also think about technical leadership from that perspective as well. Number three, the software architecture role is about coding, coaching, and collaboration. So this is a myth I wanted to dispel because, again, the old-fashioned approach to software architecture is the dictatorship approach, where architects work on their own. They produce a huge big document, and they basically give that document to a team of developers and just tell them to go get on with it. That's not how we should be doing stuff. That's how we used to do stuff in the past. And these architects also often used to use these documents as batons in a relay race. I don't like this approach. I call this approach AS. It's just architecture as a service. It's just a one-way stream of architecture decisions with ultimately no feedback loops. And one of the things I like to tell teams is that your technical leadership should be continuous. So don't think about getting an architect in for the first 2 or 4 weeks of your project lifecycle. You need to have someone doing the architecture role throughout the entire lifecycle. That could be one person, or it could be a whole bunch of people. That's entirely up to you, and we'll talk about that in a second. Different types of teams need different leadership styles. So this is something I realized a few years back, and Roy Oshrove has a great book called Elastic Leadership that talks about this problem from a team leader perspective. I think the same issue happens from a technical leadership perspective. So if you've got a team of developers and they're fairly junior and they don't really know what they're doing because they don't have much experience, generally telling them what to do and helping them in a much more direct way, in a kind of command and control way, that makes that team go faster. If you have a team of rockstar ninja 10x's, or whatever silly term we use to describe really experienced developers, don't micromanage them, just remove the blockers and get out of their way. So different levels of maturity, different types of teams with different levels of maturity need different leadership styles. Even with the immature team, the inexperienced team, you still need to give them some time and space so that they can start to understand and solve their own problems and therefore become more mature. So that's the other thing to kind of bear in mind here. And the reason I bring this up is because teams often ask me, should we have one person doing the architecture role or should we have many people? should we share the role out amongst the entire team? And it's up to you. My advice and a good starting point is to do pair architecting. And this is what I used to practice myself when I'd built software for consulting companies back in London all those years ago. So it used to be myself and another person, typically another architect, but not always. Two heads are better than one, etc., etc. In order to do that, you need good collaboration skills, and this really points to having good soft skills in general. So this is an aspect of the software architecture role that we don't talk about enough in the industry, but really this is kind of the make or break stuff. If you can't lead people well, if you can't collaborate well, if you can't influence a team well, you're going to have a really hard time doing the architecture role. So I would urge you, especially if you're moving into your first architecture roles, to put some time and effort into learning some of that soft skills stuff. Let's not forget the tech stuff. Should architects write code? My opinion on this is most definitely yes. And my preferred approach here is that architects write production code. This is definitely what I do as far as possible. The reason I like this approach is because then you as an architect have a pulse on the code base. You can see what's going on. You can see that people are following the guidelines that we've all agreed to collaboratively, and you can make sure the code base is going in the right direction. If you're a bit more hands-off, that's much, much harder to do. Most of the good software architects I know are also good software developers. So again, they have a good technical background. They might be specialists in building Java server-side apps or .NET apps or Ruby apps or iOS apps or Oracle database-driven apps. So they have some deep specialism, but they also have a broader range of design knowledge, architecture knowledge, knowledge about non-functional requirements and cross-cutting concerns and logging and operability and all that sort of stuff. And this is super important because if you're designing software, you need to understand technology in order to assess trade-offs. Unfortunately, there's no perfect silver bullet solution to any problem. So, any decision we make is going to have trade-offs. And if you don't have the prerequisite technical skills, again, you can't answer these two questions that I outlined before. So the software architecture role, it can be done by one or many people, but it's multifaceted. It requires good tech skills and good non-tech skills. Number 4, my favorite, you don't need to use UML. This is one of the things that for some reason scares people off doing a software architecture role. When I do these talks in front of a live audience, I ask people how many people here use UML, and typically it's in the kind of 1 out of 10 ratio. There are a few exceptions to this. It varies country to country, culture to culture, but generally it's about 1 out of 10 people. So not a huge number of people these days using UML. Why? I've heard every excuse you can possibly imagine. It's too complicated. It's too detailed. The tooling sucks. You'll be seen as old-fashioned. Or in the case of this guy, he said it's a very elaborate waste of time. That might be true if you overuse UML. I mean, UML is just a language. It's just a notation. You can overuse it. You can underuse it. It's entirely up to you. What is the recommended advice these days in terms of diagramming and presenting your designs in a visual manner? Well, the answer many people give you is just use a whiteboard. And that's okay. That's a decent piece of advice, but unfortunately it provides absolutely no guidance. So one of the things I typically do when I'm allowed to travel and we're not in a pandemic is I get to travel around the world and I run Carter's architecture workshops, design workshops, where we get people into groups, we give them some requirements and we say, go away for like an hour and a half and do some design and draw some diagrams to illustrate and showcase your solution. And the diagrams look like this ultimately. So this is boxes and no lines. This is my favorite. This is like the airline route map. So that green blob is Amsterdam Schiphol or London Heathrow. It's like a big airport hub, lots of routes around the world. This one here doesn't even tell you anything about the business domain. It just says business logic in the middle. Wow. This one has no tech choices. This one is a bunch of C# things floating around a database. Are these components or modules or microservices? I have no idea. This one is like an adventure game. Start at the top, go down, follow the different arrows. No matter which path you choose, you always die and end up in the trap on the left-hand side. It's rather unfortunate. This one here has a couple of unlabeled users that I call stormtroopers. They're just faceless, anonymous clones attacking this reporting service, or you get a mess. Now, I've got gigabytes and gigabytes and thousands of photos kicking around on hard disks from my workshops over the past 10 years, and they all look like this. And people often say, well, what happens if you let these groups use a tool and not pen and paper? Well, guess what? The same thing happens, just in a tool. And you can see this yourself. If you go to Google and you do a search for software architecture diagram, you get the same garbage, but it just looks nicer. We've got nice colors and fonts and shadings, but we've got different sized boxes for unknown reasons. We've got acronyms, unlabeled lines. It's just a mess. The reason I put so much focus on diagrams is because if your diagrams don't make sense, you can't answer these two questions, right? You can't have the right conversations to even start answering these two questions. So I think teams need a ubiquitous language to communicate effectively. And I'm not talking about a DDD, domain-driven design ubiquitous language. I'm talking about a visual ubiquitous language to describe software architecture. Now, we could use UML. I mean, UML is a perfectly good ubiquitous language for describing architecture, but nobody wants to use it for a whole bunch of reasons. So something I came up with a number of years ago is called the C4 model. And it's a set of hierarchical diagrams that you can use to describe different levels of abstraction in your software systems. C4 stands for context, containers, components, and code. And the easiest way to think about this is it's like diagrams as maps. So if you go onto Google Maps and you start at very high level, you're flying over the landscape of 30,000 feet, the lower you go, the more detail you see. So it's the same thing with the software architecture diagrams. We've got different levels of diagrams that show you different levels of detail. And those different levels of diagrams allow you to therefore have different conversations and tell different stories with different audiences. The C4 model does not prescribe any particular notation. So it's notation independent. You can use boxes and lines, and that's what most people tend to do. You can also use UML or SysML or Archimate. I do see teams occasionally do this, but typically it's boxes and lines. And if you're going to have boxes and lines, you need a diagram key. That's the most important thing here. So really the C4 model is about having a common set of abstractions and a variable of varying notation. You can find more information about that on c4model.com. One of the questions people always ask me is, what tooling do you recommend? And something I was pleased to see in the ThoughtWorks Tech Radar a couple of weeks ago, the new version that came out, is that diagrams as code got a mention. It blipped on the radar in trial, as well as the techniques. So this is where you're creating diagrams using a textual format, like a domain-specific language or maybe actual programming language code itself. So when we were in lockdown, deep in like April, May time, because I had nothing much to do, I built a domain-specific language. It's called the Structurized DSL, and it was specifically designed to support the C4 model, and it lets you create C4 model diagrams with quite a succinct domain-specific language. It also supports things like cloud architecture diagrams, because lots of people seem to be wanting to draw those sorts of things these days with all their Amazon icon sets and stuff like that. The most powerful feature about the Structurized DSL, and the Structurized DSL is accompanied with the Structurizer command line interface, and both of these things are open source and available on GitHub. The most powerful thing about the Structurizer DSL is you create a single file, a single source file that contains, essentially, it defines a model of your software system from different levels of abstraction, and then using the Structurizer CLI, the command line interface, you can then generate multiple diagrams from that single source file, and you can also generate those multiple diagrams in multiple formats. So you can use multiple rendering tools to essentially render those diagrams. So in this slide here, I've got a single source file, and that's been rendered using PlantUML, Mermaid, Iliad Graph, and my own Structurizer tooling. So that's a really nice way to get a bunch of diagrams very quickly and try out lots of tools without actually getting locked into any of them. So that's my thoughts on diagramming. The last thing I want to very briefly talk about is that a good architecture enables and gives you agility. So one of the things we've kind of heard over the past couple of decades is that you've got this agile thing, you've got this architecture thing, and they're somehow different and they're competing, and that's actually not the case. from my perspective, they're actually complementary. What is Agile about? You have a number of different ways to think about Agile. For some people, it's about moving fast and embracing change and getting feedback and delivering value quickly. And really for me, that's the process or mechanical side of Agile software development. And in essence, really, it's just incremental and iterative development done really well and really rapidly. For other people, Agile is more about a mindset of continuous improvement. So we're never just doing stuff all the time without looking at what we've done and how we can improve it. And I think this is really what we want to be kind of more aligning ourselves with. From that perspective, then, one of the things I like to say to teams is, well, think about agility, which is the ability to move fast, as a quality attribute. And think about where you need that agility. Do you need that level of agility across your entire code base? Or maybe do you only need agility in certain parts of your code base that represent particularly volatile parts of your business process, for example? Once you have that in mind, you can then figure out how to support the appropriate level of agility. So do you go monolith, do you go microservices, do you go a hybrid approach? Maybe you have most of your stuff in a monolith with some stuff around the outside of your monolith as microservices, because that's more volatile and that's where you need more agility maybe. A good architecture buys you agility. So a good architecture enables agility. What do I mean by a good architecture? It's kind of subjective, but for me, a good architecture is really, it's really talking about something that's well structured and highly modular. And this kind of makes sense, doesn't it? If you've ever worked on a code base that's a horrible big ball of mud, when you change something over here, all this stuff down here breaks and you're not really sure why, that slows you down. On the other hand, if you've worked on a software system that's very well structured, and when you make a change, that change is isolated into a small block, a small unit of your code base, that clean structure allows you to move much faster. You don't get that characteristic for free, though. You don't get agility just by hacking out some code and kind of hoping for the best. So you need to put some thought into this. George Fairbanks has a great book on software architecture called Just Enough Software Architecture. And in that book, he says this: a good architecture rarely happens through architecture indifferent design. What's architecture indifferent design? It's basically just choosing a solution. It's making decisions because that's what we've always done in the past. So I see that a lot, especially in big companies. Or people are making decisions because of trend, hype, and fashion. And I see this a lot these days, especially with things like microservices and serverless-based architectures. So they go and see a new team, and they're like, we're going to build a new system, and we're going to use microservices, we're going to use functions as a service, and we're going to stick everything else in Kubernetes. Like, why? And they're, because why not? That's not a good way to make decisions. A couple of years ago, more than that, 5 years ago, I threw this tweet out. And I said, if people can't build monoliths properly, please don't adopt microservices, because it's not going to help you. And I still see this today. I see large organizations, and they have these legacy 10, 15-year-old Java code bases, and they're just horrible big balls of mud. They're horrible monolithic applications. And they think the only way to fix this is to go microservices. And what they do is they start essentially from scratch with a view to rewrite their monolith as a collection of microservices. They have the same mindset, and what they basically end up with is a distributed version of what they had before, because they don't realize they need to take a different design approach. And then at 2 years down the line, like, oh, this is really slow and brittle, and we have to lockstep deploy everything up. I'm like, I know, you're thinking about this the wrong way. So you need to put some thought into what you're doing. So that tweet got a bunch of retweets, which I was quite impressed with. But then I got completely outclassed by the architect Clippy. I see you have a poorly structured monolith. Would you like me to convert it into a poorly structured set of microservices? No. So again, just make sure you think about these decisions before you make them. You know, significant decisions are the things that are hard to change. So that's me. 5 things every developer should know about software architecture. Thanks for listening.